In this video, we are going to be looking at the gradient of a line. Now, the first thing I would like you to know is that another name for gradient, so also known as, another name for gradient is slope. So anytime you see slope, it's the same as gradient. Now, the next thing I want you to note is that every line has an equation. Now, this is the general equation. We have y equals to mx plus c, general equation for a line. Now, where this m here as the gradient or the slope, then c is known as the y-intercept. Now, for this to make perfect sense, I want you to understand that in this context, when we are talking about line, we are talking about it in relation to a graph. Now, to really understand what we mean by gradient of a line, I need to show you what it means in context of a graph. Let's do this. All right, so here's a graph. Definitely, you can see the graph below here. Now, on a graph, a line is not just a line from anywhere just placed on the graph. Actually, a line graph is gotten when we plot something against another thing. Now, in a real life situation, if we have a vehicle and this vehicle has a distance it's covering at a specific time. Now, I have a table here. Now, let's say this is the distance on top. And so the car covers 2 probably meters in one, maybe second, and then it covers 4 meters in 2 seconds, 6 meters in 3 seconds, 8 meters in 4 seconds. Now we can plot this on a graph, and when we plot this on a graph, we have a straight line graph. Let's try to do that. So this is a graph here. Let's say on this y-axis we have the distance, and then on the x-axis we have the time. Now for the distance, 2 corresponds to 1, so we have this point here. 4 corresponds to 2, so we have this point here. And then we have 6 corresponding to 3, so we have this point here. Then we have 8 corresponding to 4, so we have this point here. Now you can see that this here is a straight line. Do you understand what I mean? So a straight line does not just come from nowhere. It's actually we are plotting something against something. Now let's now go to the topic for today, slope. Now the real meaning of slope in maths is actually rise over run of a straight line graph. Rise over run. Now what that means is that you can see this graph, we have the height, which is the rise, and then we have the breadth, which is the run. So if I'm told to calculate the slope of this line, all I need to do is to try to form a triangle. So I can have any triangle. You can form a triangle from any part of the line. All right, so now remember we are doing rise over run. So I'm trying to find the rise over the run. Now let's try to find the rise. How many steps did it rise? So we have 1, 2, 3, 4, 5, 6. So the rise is 6 over how many times is the spread? Did it move to the right or to the left? So we have 1, 2, 3. So 6 over 3. Now 6 over 3 is 2. That means the slope of this line graph is 2. Now in the real life situation, the slope of a distance time graph gives us the speed. I don't know if you understand that. So when we have the slope of a distance time graph, we have the speed. Do you see that slope is actually something that can be related to our daily life? Now, for example, if you are a science student and you've done speed in physics, you know that the formula for speed is actually distance over time. So if we try to calculate any of the speed of the variables we have in this table, let's pick 4 and 2 for example. It means that the speed will give me 4 over 2, which is 2 meters per second. Can you see that that is what we got in the slope 2? So for a distance time graph, the slope is actually the speed. Now, do you understand that? Now, let's solve some examples, but now using the number formula you will get in school. But all I need you to know is that in the real world, slope can be related to our daily lives. And it's important even to us as human beings. Let's do some examples.